Okay, so today we have a new box from BG Practice. Not everyone is going to have access to this, but it's okay. We're going to be practicing on some platform, or like showing the session on one platform, and then I can give you guys boxes to practice on later on. So let's get started. So first of all, we're going to start from one IP address. Let's get my note-taking cherry tree out, because we're gonna be practicing. This is all, like, I know it's fun to take a box and try to hack at it, but at the same time we want to be learning how can we apply this in an actual like in-demand skill kind of thing. So we want to be doing practicing our penetration testing, practicing how we can write a report, how can we take notes, and how can we do these stuff simultaneously, not just like hacking and being script kiddies and that kind of thing. So we're gonna be practicing note taking. Okay, that was our previous Blum box. So let's have one for this one. It's gonna be Exghost, and yes, so now we have two notes, one for Plum, one for Exghost. So let's start to have maybe like a header, and let's control one. So here, this is going to be Exghost. And the only piece of information that we're going to start out with is going to be an IP address. So let's have that piece of information here. And let's grab the IP. And we talked before about how penetration testing is it's a tree. You start from one node, literally most often is going to be an IP address, maybe a range if you're in a corporate environment. But most of the time in these boxes, we're going to be starting with just an IP. And from that IP, we're going to enumerate. And by enumerating, what we mean is expanding our information on that node and branching out into more information. And slowly, as we gather more information, we identify branches and paths that are vulnerable, and we can take advantage of and exploit. So that's the idea. So let's start with the only piece of information that we have. This is gonna be this, okay? So from an IP, what can we do? We can expand on it by getting the services running on that IP. Because like right now I have an IP, like where do I even start on this? Maybe we can, for starters, we can maybe Bing it. So we can interact with it. Okay, it seems to be up and running. Let's start scanning it. So I'm gonna do the typical scanning with our nmap. So we're gonna have -t4 for a faster scan. I'm gonna have -vv, triple V, for verbosity, increased verbosity, so I can see more information on my screen. And I can have -b- to scan everything that I encounter. And I don't know why I want to cancel the auto completion. Let's have an extra space here to run it up. And we're going to have -sv to enable version detection. And I'm going to have -sc to run some default scripts. Nmap comes with a useful set of scripts that can enumerate or scan multiple services. And I'm going to put in my IP address here. Okay. And let's actually do save this. So I'm going to do on to specify an output file, and n to specify the nmap format, which is the common plain text nmap output format. And I'm going to put in the name. So it's going to be nmap full port. Okay, .nmap there. And let's review our command. Looks about right. And maybe we can add sudo to enable faster scans. Stealth scans are only enabled in sudo. So let's type in my password, Kali. And here we go. It started scanning. So now, as you can see, from a single piece of information, we started to get more information. We're branching down that tree and we're getting more information. So two things. We have to be adept at gaining or extracting more information from less information. We should be able to have the ability to extract more information. And this, at the same time, when we get that more information, we should be intentional. We should have the ability to filter and scan that information for the things that matter. So it's not about just like scanning and getting all the information possible, although that's useful at times. But at the same time, you need to be able to interpret that information that you branch and come out with, and be able to interpret it and filter it for the things that matter. And that's how the entire process becomes successful and effective. So while this is running, I'll leave it here. I'll keep it running, but I'll check the immediate outputs I have here, like right before Nmap finishes. So there's port 80, and commonly we know that port 80 is what? It is HTTP. So let's grab that. So we know that there is a website running on this server. So let's try and see it. And it seems like we do not have permission to access this resource. Could we possibly scan it? Because it seems that this server running here, it is giving me, let's actually check the network, and we're getting a status code of 403, forbidden. So there seems to be some sort of protection on this website. Interesting. Um, before scanning this website, let's actually check the other one. Maybe there's some clues in this other port. And again, 21 is what? We can check that out, but from experience, we know that 21 is usually FTP. Okay. So let's actually create a new tab here, and I'm going to try and access this FTP. And you can notice that every tool goes to its default port by design. By, for example, the web browser, when you give it an IP, it goes to port 80. An FTP client, when you give it an IP, it goes to port 21 without even specifying it. But each tool is going to also give you the option to specify like substandard or non-standard ports. So I can do 80 explicitly, and it's the same thing. And here as well, if I do this, let's try. And name, it's asking me for a username. Let's try something like maybe guest. And let's try some password as well. Nope. Let's try the common, let's give it, tell it by, and let's try something like anonymous. Usually FTP servers have something called an anonymous account, and it could be enabled at times. So I can say anonymous, and it's asking me for a password. Anonymous accounts, usually they do not require a password. So let's see if maybe, is that allowed? Login incorrect. Interesting. Could we do, let's see, what can we do? Let's see if we can actually scan this website, because it said forbidden at the home page. Maybe there's some other page that we do not know about. So let's go here and let's actually clear this. And I'm going to do something like FUF, or we can do, I prefer FUF, so we can do FUF, which is a tool that allows us to scan websites, HTTP servers, enumeration, directory enumeration. So I can do something like this. Let's have HTTP, just to be clear. And let's have a placeholder. It's going to be called fuzz. That's going to be the place where we want to scan things. So we're going to try different words here and see if there's different directories that we can look at here. And I'm going to give it a big word list, a list of files and directories that we can scan. So maybe I can do something like this. I know I have this list here on my system, and it is like sufficient most of the time. So let's try this and see what happens. Okay, let's leave it for a while, and meanwhile, let's actually get to taking or recording the things that we've done so far. So in map, so let's say that we ran this command, copy that, and let's put this here. So I'm going to have port enumeration, and this is going to be level 2, and we're going to insert a piece of code. Let's remember the shortcut where is Control Alt C. So Control Alt C and automatic syntax highlighting, and we can have that, and we can paste this. So this is our snippet here, and we can actually put some of the results. So we can say that we found it actually did finish. So we can notice here the extra scanning or information that Nmap provided to us, and we can actually grab these and save it. Okay, so now we have some command output. Let's say that let's dedicate a header or a section for each service that we've encountered. So there's HTTP at port 80. So let's do that. So I'm going to have 80 TCP, and we're going to have to maybe color this. How did we think it was Alt Shift F? Yep. And let's give it like some color, green. No, not that. So yes, green, select, here we go. And let's make it actually bold. And this is the first port that we looked at. And let's type some notes, because we want anyone who is reviewing our work to be able to tell us or like be able to review our work and see what exactly have we done. And we want ourselves, because this tree that we're talking about, it can go and spiral out massively, and we can go into rabbit holes, and we can go into dead ends and stuff like that. So it is important that we keep clear descriptive notes that we can come back to, and so we can come. I better see us scan. So we can better come to to these notes and maybe repeat our work, or maybe review some step that we missed, like maybe we did a mistake, and if we don't have these notes, we'll be able to identify the mistake that led to the entire tree being wrong, the scanning tree, or the conceptual tree we're talking about when we're doing pen testing. So that's why we need to take notes. And again, at the end of the day, when you're doing penetration testing, notes is going to be your primary deliverable. That's the thing you're going to give to a client. You need a report, not a note, but from that note, you're going to create a report, a well-fledged report that's professional, that includes things like how can you fix the vulnerabilities that you have identified, how can they be remediated, stuff like that. So I will keep it simple. The notes are going to be simple and maybe informal for this session. So we visited the home page, and it returned 403 forbidden. Okay, and let's have another one for the FTP, and this is going to be 21. Oops, 21 FTP. Okay, the formatting is okay. So 21 FTP, and we attempted, let's put the attempts that we've done. Login with guest, anonymous, but nothing. So it was like we had nothing, but none worked. Okay, let's see what can we do. Let's get back to our, this is our, interesting, but this is now our results, our scanning results. So let's actually copy this, all of this, and let's see what can we do here. So this is HTTP. We started scanning for directories using FUF, and we found this. So let's Control Shift C. And always, whenever you find a tool that you're using often, try to get accustomed to the shortcuts it has. It saves you time. So for example, Cherry Tree, I don't use it much. I use Obsidian, but for Cherry Tree, let's do Control Alt C, get this, and let's paste Okay, so I messed up the paste. So get back here and paste it. And here we go. And now we have the results. Now, even if I lost this in my terminal, I still do have the notes. So I can get back to it and know what directories I have identified. I can even look at the word list that I have used. So I know if I am to repeat the scan, I know to use a different word list to not repeat my work and waste time. So that kind of thing. So it seems from the results we have HT password 403, we have HT access 403, forbidden, but we have something called uploads 301. So let's actually check that out. Uh, Uploads, and it does redirect me into a forbidden as well. Hmm, interesting. So what could be going on here? Any ideas? What could we do here? We have a professional penetration tester here, so there's no way to get stuck. Okay, he left us. Okay, so we're stuck. So let's continue. I think one thing that we could do, looking at the nmap scan, actually now that we have saved it, if we clear this and we can look here, I can look at the nmap full port scan that we've just done, and we can see the results. So it's good thing that we saved our evidence, if you may say. One thing or one clue that we could look at is these version numbers. So maybe, I don't know, maybe there's some vulnerability in this version number or that version number. Let's actually check this one. So I'm gonna come here and I'm gonna search for FTBD 3.0.3. Do we have something? Backdoor. Hmm. Vulnerabilities in VSFTBD. It seems like it's fine, right? Let's check this one. Hmm. Security vulnerabilities. No, 2.4.41. I think it's secure as well. So what could we do? What can we do? Any ideas? Maybe let's try and look for default credentials, maybe. Because maybe like literally the all like here on this HTTP server, everything is pretty much locked up. And the only thing that like there's no inputs, there's nothing that we can interact with. The only thing that we seem to be able to interact with is the FTP server. And it's probably there for a reason. So maybe let's try and enumerate it. So maybe I can try something like Hydra and I can give it the IP. So let's go back to our notes and get the IP. And Hydra is a tool that allows us to perform brute force over a network. Okay. And it supports different protocols. So in this case, I want to attack FTP and I want to give it a list of logins. So let's try different logins maybe. And you give it a file using capital L. And let's try maybe like empty password. And the file I'm going to give it maybe word lists. Maybe I can give it sick lists, discovery, or maybe sick lists usernames. We do have a list of usernames, and let's try something like I don't want to have 10 million usernames. Top usernames, maybe. Let's try this. Do we get a hit? Like, do we get anything special from this? Zero valid passwords found. Let's try something like. So I think in Hydra you can have something like. So I'm looking for an option. There's an option like to use the same username for the same in the same position. Okay, so E and SR. So let's look at that. E dash E. Okay. Okay, so N for null password, S for try login as pass, R for reverse login as password. So let's try that again. So it adds like different options for the uh, for the password. So password based on the login. Dash E, it means use no password. Dash S means use the same username as the password. And R, use reverse. Maybe you can use a bigger name, word list. So maybe, should we try the 10 million one? Let's see. And actually, I think we do need to do capital V to have things presented to us as it tries. Interesting. Can we have something like maybe VSFTBD, default credentials, maybe? I want to see maybe there is some default credential that we could use. Okay, so there's a write-up that says, and it's okay to look at write-ups. So when you get stuck, instead of staying stuck for 3, 4, 5 hours, after you tried whatever you have in mind, you can like just look at the write-up and clear that obstacle in your way and move on. So the write-up says that there's indeed an FTP login weak credential that we could have found, and it is at user and password is system. Can we try this? It is indeed the correct answer. Now, how could we have found this? I'm not sure. I'm not sure. So we could, because we user is a non-default or like non-standard name. Usually it's root or something like that, and we could have brute forced the password, but I'm not sure how could we have identified this username. So that's very interesting. But anyways, now that we have this piece of information, we can do, let's do FTP. So which one did we have? We had it here. So let's do FTP, and that's our FTP command. And I'm going to do user. And you can do control. So if I'm here and I do control R, I can backward search through my previous commands. And if I type FTP, I can get this. Now we actually want to log into user system. That's how you specify your credentials. Username, colon, system, and then at the IP. And this is part of the URL specification. So if I do this, it's asking me, I think you need to, shouldn't ask me for a password. So if I think we might need to put it here. Nope. Okay, let's do system. Failed. So I think it's reading this whole thing as a username. So let's do system. And here we go. We logged in. So now we logged into that FTP server. We want to know what we have on this server. So let's do ls, entering extended passive mode. Go ahead, Ahmed.
Adham, sorry, could you just please like summarize what happened? How did you get access in
So
simple terms?
we had an FTP server, but we didn't have valid credentials for it. So we tried brute forcing the credentials, and we couldn't because we did not know the username or the password. So we were essentially brute forcing two things: the username field and the password field, which is almost infinite combinations. So I got stuck at this point. I looked at the write-up and we identified the user and the password. And that's how we logged in. So we went to FTB, and I'm gonna fix this in a second. So we went to FTB and we logged in as a user, and we typed in the password system, and we logged into that service. So did we type it? So we can do user, or we can do, I think, login user, and it's user password system. So login successful. And I'm not sure if there's a hint to this name, this username anywhere in the on this machine, maybe like somewhere in the speech. I'm not sure, but there's no hints on the username, so I'm not sure exactly how could we have found this. But anyways, if we log in now to the server, did we to the FTP server? Now we are logged in, and you'll notice that we can't type. So whenever we type something, it's gonna go into extended passive mode and get stuck. And that's for a reason. If we look back here and we look at the open services, you'll notice that we had port 20 FTP and port 21 FTP and port 20, which is FTP data. And that's if we read about the FTP protocol, you'll see that FTP has two modes of operation: passive and active. In passive mode, it allows you to have one port to control the FTP connection. So that's where we're connecting right now and sending commands, and one other port to send the FTP data. So it's like in parallel. One port for control, which is FTP, and the second port is for data transmission, which is FTP data. This is passive mode. Now we could force FTP to run in active mode, where the same channel, port 21, FTP is going to be used for both control and transmission. In this case, port 20 FTP data is blocked. You can see it returned a reset, TCP reset, and it's closed, so we can't access it. So passive mode is going to fail just as we were seeing here, passive mode. So we need to force it somehow to enter active mode. So let's actually log in again. So I'm going to do user, and system. And let's actually look at the help and see how can we move this to active, because there is a command to move it to active. Can we do something like this? Active um, mode active. No, that's a different thing. I actually forgot how we can do it active from FTP, but we can usually do exit, and we can do like dash capital A here to force active mode from the get-go. Did someone send something? There's no messages? Okay. So that's what we can do. So we can do system, and now we're in active mode. Let's do something like ls now, and here we go. The command works. It doesn't hang as before, and we're getting connected. So there's some file called backup. Let's try to get it. So I'm going to do get backup, and now it's downloading that file to our system, and we can type in by. We pretty much got everything that we need on this system. So let's actually copy this, and let's actually, yeah, up to here, and let's go all the way to the FTP, which we cheated and found credentials user system in a write-up. And here we can say brute force failed since we had no valid username. And here we can do Shift C or Control Shift C, code, Control Alt C, and we can paste in this information. So we can come here and paste in this. So we logged in to FTP, we found the backup file, and we downloaded it. Okay, so let's see if we can now look at that backup. Maybe it has something in store for us. So let's see. I'm gonna type in by. Let's clear. Let's look at let's ls. We have now that backup that we exfiltrated from the FTP server, and let's look at the type of that file. And it turns out to be a packet capture file. So let's do Wireshark and give it that backup because it's a bcap. It's a network traffic capture that we can look at with a tool like Wireshark. And now you can see how the CTF knowledge can be useful here. So things that we seen with Omar in the CTF can be actually useful here. There's lots of DNS queries here, so you can see this is DNS standard query, standard query. So let's actually filter that out. I'm gonna type in not DNS, and now that's much better. There's something called MDNS, so and not MDNS. I want to remove that as well. And now we filtered it down to something simple. And let's look at this. So it seems to be some traffic from local hosts. So they're both it's local traffic. So from the same device, and we can see here the server that is being targeted is port 80. Okay, so there seems to be some web traffic. Could it be possibly the site that we were just looking at? That's very possible. But let's look at this. So what is happening here? Let's look at actually and http.request. Okay. I want to look at the HTTP request. I want to know what traffic was getting hit in that instance. So there's two, and interestingly, there is something at /exif_test.php. So if I look at this is the first request. And if we look at that, that's a second request, and it is a post request. So there's maybe some upload thingy going on here. So let's try if we and see if we can access that information. So we can say, actually, let's take a screenshot. I'm going to use Flameshot, and we can copy that. And it's actually so in the screenshot, let's make a highlight over this. Okay, and we can put it in our notes. So we found the backup to be a packet capture bcap file, and we opened it in Wireshark. So that's the beginning of our new chapter, and we can have something like backup bcap control 2, and we can put the screenshot in here. Okay, looking through the traffic, we identified a local /exif test.php route. Okay, so that's something that we found through the backup. So you can see how new information opens up new information for you. Let's look at that. Exif info, is it? So what was it called? Exif test. So we can have exif test.php. And indeed, there's a page that says exif test.php. And this file we did not identify because it's unique. So exif test.php, I don't think you're gonna find it in most word lists. So that's why we had to find it this way, or we could only find it this way. So there's no file to upload, so it seems like we need to upload some image. Now, let's actually look at the Wireshark again. Let's see how does it look like? How does a request to this endpoint looks like? So this is a request. It has some JPEG image. We can scroll all the way down and we can see the output, the response. And it seems like this image is going through, like the image in the request is going through, it's getting uploaded and it's going through this tool, exif tool. And exif tool, if you did like these forensic CTF challenges, you know that it is used to extract information, metadata from images. So it seems like this version number is being used to get the information about the image. So let's actually look up this image, this version number out. And wait. I did actually have, there's something here Firefox suggesting to me. Maybe because this version is known, or maybe I did this something similar before. But there seems to be an arbitrary code execution vulnerability in this exact version, which is crazy. So let's grab this. There seems to be an exploit even for it. So let's actually take this, copy it, and this exploit allows us to generate an image that contains like the vulnerable code that can give us that contains the exploit. So let's actually we copied the code here. Let's keep actually Wireshark. I do need it, but here I want to copy the exploit. So exiftool exploit.py. It's a Python script, and let's see what can we modify in this script. So if we go up here, we can see that. Okay, so you can use it from the command line, and you can pass it the local IP and the local port that you want to be uh, listening at. So let's actually, and what does it use? So let's look at the command that it uses. It uses, I think that's Perl. It's Perl. System execute. Is it Perl? Yeah, it is Perl. But where does it run it in Perl here? I think maybe exiftool by default, it has some Perl interpreter maybe. But let's actually, this WQ, let's actually review this. We don't want to get hacked. Okay, I'm willing to risk. It looks fine. So let's do Python exiftool exploit. Okay, we don't. Well, let's actually fix it. exiftool exploit.py, and let's do Python exiftool, and let's do -h for help, and let's give it my local IP. So my local IP is written up here, 45.192, and let's give it my local port, the port I'm going to be listening at. So this is what we call what we're generating right now is a payload that is going to connect back to us, or what we call a reverse shell. A reverse shell. So I'm going to be listening here on my port 443, and I'm going to create an image, a vulnerable image or a malicious image that when uploaded to exiftool is going to execute code on the server and is going to connect back to me. So if I do enter, exploit image written to image.jpg. So it seems like everything is successful, and we can look at image.jpg. And this image, supposedly, if uploaded, can get us code execution on the server because it exploits some vulnerability in exiftool, which is being run here. So let's take this. I want to send the request to this endpoint, which takes an image, and I want to upload the image here. Let's see in Wireshark how is it uploaded, or in what format is it uploaded. So it's uploaded as my file. Okay. So we can do that with curl. I can do curl. I can give it the endpoint, and I can give it a file using -f, and I can give it the name, my file, and I can give it at to signify a file in my local directory. and I can give it the name of the file. So image.jpg, that's a file in my current directory. I can even do this to show you that it is a file. And let's see if this works. And let's actually make it verbose. So -v to make curl give us verbose output. And wow, it did work. You can see we have completely uploaded the file and fine. And right here, we received a shell. Let's actually exit and show you this again. Once we exited this process, you can see that the request did complete, so file uploaded successfully. But let's actually clear this and let's do this again. So are you following? We have this here, it is listening, and I can run this command and upload the image to this endpoint. And the second I do that, look up here, the second I do this, we do get a shell. So now we are connected, or we have exploited this machine. So let's look at the first thing we will do. So who am I? I am data, which is your typical web host for Apache, and it is unprivileged, so we don't have much privileges. Let's see if we have Python 3. We do. So let's actually make this what we call a TTY, or like short for an interactive shell. So I can type in TTY, and it's going to tell me that I'm not in a TTY. But if I do Python 3, C import bty bty.spawn, and we're going to spawn a pin bash or a bash shell. And if I do enter, now you can see how even the prompt changed. So from this, now I'm actually running in a bash interactive shell. So TTY, and you can see this. And thanks to my R grab here, I can use the upper arrow keys and I can move around. So it's a relatively stable shell. So now it's time to do what we call privilege escalation. So actually, let's see if we have any flags here. Let's see my home directory. Home is not set. So maybe let's find iname local.txt. Do we have any local flags in this machine that we can submit? I think it's just one flag probably. So let's see if we can privilege escalate. Let's look at the running services inside this machine. So something like this. And there seems to be local DNS, 80, the web server, FTP, there's SSH, but seems to be like blocked because we could not identify it earlier. So there's a firewall probably. But you can see now that we've moved inside the machine, we are enumerating further and trying to find more information. So every step allows us to find more information. We gather that more information and we use it to exploit the machine. So let's see, what do we have access to here? To make enumeration easier, I would move something like Linbees, a tool that automates enumeration, and move it to this server. So one way we could move it is through FTP, because we know that we have FTP. Let's Control C, exit this. I have a script here. So if we look at lsopt Linbees, do we have it here? No, we don't. So let's I think locate linbees.sh, and I have a couple of versions. So let's take this one, and I'm going to connect back. So same FTP server. I want to move this. I want to move it to the machine. So if we do this and type in the password, I can put this into the machine. So I can do put permission denied. Okay, so it's a read-only FTP share, so we cannot do this. Okay, what we can do, on the other hand, is I can you can see the task we're trying to do here, right? So we're trying to move this script that will help us scan or enumerate the system. We're trying to move it onto the system. So there's lots of ways we can do this. First of all, let's actually copy this into here. Okay, so now we have it, linbees. And I'm going to do Python 3m dash m http.server 80. And now I'm running a simple HTTP server on my machine, this machine. So let's try and download this linbase from my server, from the target. So at the target, let's see if we do have wget. Yes. And I'm going to do something like, let's actually cd into temp, and let's do here, I'm gonna do wget and 192.168. Wget is a tool that we use to download files um, using HTTP, and this is the name of the file, linbase, and we press enter, and it is downloading. You can see, and the connectivity is internet is slow between these two machines. If we look here, now we have the script. I'm gonna change it, make it executable. So linbase.sh. Now it's executable, and if we look at it, we can now execute the script. Okay, so I can do linbase.sh, and it is now running. Now linbase is a automation script for privilege escalation. It's going to scan the system that we just acquired a foothold on. It's going to enumerate it and find potential vectors, the vectors that allow us to escalate and get higher privileges. So misconfigurations, maybe known vulnerabilities, vulnerable software, services, stuff like that. It makes things more systematic and avoids you forgetting something that could be trivial. Okay. And I can already notice a couple of things. So there's some kernel exploits. So it has sections for each type of vulnerability. So there's like Linux kernel exploits here. We can look at different. See, it detected, for example, that this is running inside a VMware virtual machine, that kind of thing. You can see different services running on this machine. So it's scanning everything, and you can see Apache that we saw, and we can confirm this because we know there's a web server running here. It's running as lub data, and it can show you, actually you can see our own command. This is a command that we just launched. So that's the image that we uploaded, and it's still running, it's still hanging because it is a command execution. And you can see the things like the child processes. So that's our reverse shell. That's our like this came out of the reverse shell. This is our Python 3-C that we did early on, which executed bash, which executed linbase, and you can see the different things. So you can see all of that. Now, something that's interesting here I noticed is this pseudo version 1.8.3.1. It's highlighted in red, and that means it, like as a hint, you should take a look at it. So let's actually search that up. So sudo, and lucky us, like there's actually something such as sudo 1.8.3.1 root exploit, sudo heap overflow. So there seems to be some exploit available for this. Let's look at the first one, and it seems to be some C code that is provided, exploit.c, and sudo edit shellcode.c. Okay, so what do we need to do? Okay, so we need to make it, use make, and it's using shared libraries. So let's actually copy, let's clone this repository. And let's actually see, because I don't want to go through compilation and stuff. Let's see if we can, let's fork from this one, root shell. Let's see if we can find a Python version. So sudo 1.8, or like something that doesn't require compiling. Python POC. Is this the one? So what's CVE? Let's see the CVE number. It's CVE 2021 3156. So let's see. BOC, so proof of concept, Python, GitHub maybe. And this is like this what we're doing right now. It's a whole like it's a thing on its own. So being able to locate and identify public exploits, it's a thing on its own. It's like it could be difficult at times. So let's see. Hmm. Okay, I guess I will have to clone this. I'm not sure what is the difference between this fork and the original one. So it's 2 commits behind. We can look at this. Okay, so he just added. Okay, so it's the same exploit. So we probably, we probably will be fine with both. So let's actually take this, clone it, and let's see if we have any compilers on this machine. So GCC, we don't, and we do not have the password. So we will be unable to compile it on the target machine. And it's important to be able to compile your exploits. Let's clone it on a system that is similar to the target system, because sometimes you have different dependencies on your system, and if you combine it on your system and move it to the target, it's not gonna work. So that's why we wanted to find the Python alternative, but for now that's not an option. So let's continue. Yes, so let's do enter and let's do make. Actually, we need to see, it says shared. We need to change this to static. So if we look at CC or man GCC, what's happening? Let's nvim the make file, and let's, okay, so it's using that. Let's change this to static. So we're combining it in a using static. So the final thing is going to be one file that is all contained, so all dependencies into it. So you can see that sometimes you would need to modify the exploits that you download. You can just run them out of the get-go. So it's wq, and let's see if we can make this again. Cannot create directory file exists, so let's actually remove libnss-x. And what else do we have? So yeah, we can make again. Let's remove make. Cannot find entry simple. I think we can. This is not. Let's remove exploit. Let's remove libnss. And let's see. I think we can remove this. So we don't need static here. This can be shared. But the final exploit compilation can be static. So if we do this and we do make, here we go. We do have the exploit. And if we do file exploit, you can see that this is a statically linked binary, and we can move this to our target. And let's hope that this actually works. There's lots of messed up stuff going on here, but let's see. So let's do Python 3 and run the server again. And going back, this exploit is going to help us or allow us to reach root, because it's going to exploit the version that we've identified here, the pseudo version 1.8.3. So I'm going to do wget, and I'm going to copy it from my file, my system, and it's at exploit. And we're downloading it, and it should be here. So you can see it here, exploit. And let's make it executable. And now it is. Now let's see if we can run it. So sudo edit role type num user file. So can we do something like user. Um, so it is a version of sudo edit. I have not used sudo edit before, but let's see what can we. So can we do like some? How do we even use it? Do we do something like dash maybe? So let's see. So sudo edit. Let's see. Sudo edit become root, something like that. Sudo edit. Okay, so it allows you to edit files, I believe. Called okay, sudo edit. Okay, so just okay, sudo edit, and we can do something like etc password data. It's still asking me for password. So do we have to? Oh, sorry, I used the actual sudo edit. So we need to use the exploits sudo edit. And I made a mistake, so let's do this again. Okay, so Python 3, and let's cd into temp, and let's do exploit, and etc password. No, that doesn't work. Pwnkit. There is some pwnkit exploit here. Can we take this? And okay, so let's do this. So let's actually remove this, remove exploit. Let's remove everything related to that exploit, because I feel okay. And let's actually, and let's Python 3, and this is it. And we can now wget 1 and 2, so we can do wget the same command. I think we can wget yes, and 268, and we can do Python 3 pwnkit.py. Creating a shared library exploit directory already exists. What is this the issue? Did this? Okay, that worked. Okay. So we can actually take a screenshot of this, and that's our proof. Let's actually include the proof, the text, cat slash root slash proof to text, and this is our flag. So we can have everything here contain, and yes, so we can actually put that in cherry tree, and that's our congratulations privilege escalation.